Yeah, I just kind of left it off for I got confused on this. So I yeah.
So you've already had time to discuss this last time. I'm gonna go into a bunch that were problematic, like D. Are we okay starting with that one? D and B? Okay. I'll start with B. Can I just add them together or something? No, that would be a completely improper use of the properties of logarithms. So really the only thing I could do is on both of these, use the change of base. Now you can use any base you like. You could choose one of those numbers. I'm going to make it all a common log, which means the base is 10. So this first one is going to be log of 6 over log of 2. Do I care what log of 6 or log of 2 is? I'm not that deeply. Log of 8 and then log of 6. And see immediately that we can cancel these log 6s. But also 8 is kind of a special number, isn't it? So yeah, 2 cubed. So this 2 cubed, now I'll just kind of cross this out and put 2 cubed there. So you can see that the 3 is just going to come down to the front, become a coefficient. So 3 log 2 over log 2 gives us 3. Or if you wanted to, it's kind of fun to play with. How about from here? Log base 8 over log of 8 over log of 2, and then use a change of base formula to put it back as a log base 2 of 8. Would that make sense also to do it that way? And do you see that that would also equal 3? You can't go wrong as long as you're using the properties appropriately. 3. Yay. Okay, so I hope that helped. I need a little, it's kind of tight here. So I think maybe one strategy people were using was setting this equal to X, which gets you into a place that is kind of like not helpful. So sometimes we do have strategies that work for particular problems, and sometimes those strategies don't work for other problems, in which case it's important for you to be able to switch it up, like Christine. You can't just be stuck on any particular strategy. So what's a good strategy here? Shane, do you have an?
I turned the top into X, so log e squared 16.
Log base e squared of 16. So you were kind of examining this, is that right? Does that make sense to examine that separate from the base? And you set that equal to X? That's what you did? I hadn't thought about this, but I'd like to see where it goes. So if we do this, and from here, this leads to.
What I said is e to the 2x equals 16.
Okay.
And then 2x equals ln 16.
Okay, so you took the ln of both sides, or you change this to logarithmic? Yeah, changing this to logarithmic would be log base e or ln of 16 equals 2x. So that this exponent is equal to ln of 16 over 2. Is that what you got?
Yeah, I changed ln 16 to 2 ln 4.
Ah. Okay, so this was 4 squared, so you brought down that 2 like that. So made it ln of 4, is that what you're saying? Nice. So this becomes e to the ln of 4.
Said that I was equal to like y.
Nice. And from there you got that the whole thing equals 4. There is one property here. Very nice. Very, very nicely done. Thank you. And I'm going to talk about this a different way. There's one property that a to the log base a of x. Does this look familiar for those of you who looked at it before? That this is just equal to x. Because we have two functions that are inverses, one's inside the other, so it kind of just cancels out. It's a property that this equals x. So when you set this equal to y, and this is a great strategy again, you should have just gotten that 4. which we could have gotten had we known the property. Any questions or comments? Eileen, did you have something?
Yeah, same thing, but I said the whole thing equal to X, but I got like, it was basically the same.
You set this whole thing equal to X? Okay. Was it difficult to get out of that?
I mean, it took like 6 steps. but
Okay.
Yeah.
So, but you made it through. Good. The way I saw it, or did anyone else want to talk about how they saw this, doing it a different way and get the same thing, that this whole thing equals 4? If you got something else, just find your error. Did anyone else want to talk about how they thought about this? For me, that e squared obviously was, and for everybody, that was a problem, wasn't it? That e squared was a problem. So I examined this log base e squared of 16. I thought, let's see what happens if I do change of base. I'm going to do just common log, log of e squared. And this helps me get that square out of there. That helps me put this over here. And exactly like what Shane did, I'm going to think about that 16 as 4 squared, specifically so I could take that 2 down there. So now I have log 4 over log of e. What is, well, and this could be rewritten as log base e of 4, otherwise known as ln of 4. So it's like, yeah, backwards change of base, yeah. Does that make sense? Backward change of base here. Right, there's a base,
Yeah.
there's the e. And then once we have that, putting this here, we once again e to the exactly where Shane got e to the ln of 4. If you know the property, then it's just much simpler when that base matches the base, or you set equal to y and things work out a little bit easier. I think kudos to you for making it through that thick algebra. Impressive. Let's do B. We able to, does this make sense? I mean, are we good with that 1/5 AB? Any questions? How do you get 1/5 AB? Well, obviously the 5th root means the 1/5, so we took this down. Okay, so ln of 6. And then where did AB come from? Is this ln of 2 times ln? Is this true that it's ln of 2 times ln of 3? Is that right? 1/5 A plus B? Nice. We have to break up that 6 into 3 times 2. Why do we have to do that? So yes, we could use these, ln of 2 and ln of 3, and then we use the properties. So 1/5 ln of 3 plus ln of 2, and like you said, Amir, 1/5. And I think you meant the quantity A plus B. So either that or distribute through the 1/5. Neither one is more simple than the other. Any questions? How did you like example 3A and B? Would it be helpful to do them? Sure. Would it? Okay. I see we have something over something, so I'm going to introduce some sort of subtraction here. It's going to be namely log of, make sure to use parentheses, x plus 1 minus log of x minus 2. Oh, thank you. It is a cube. Thank you very much. Am I done? I'm not done. It's saying to express it as a sum and or difference of logarithms, pull out all exponents. So if we could make it a sum, make it a sum. And we could see that in this first expression, we could not only make it a sum, but also that 3 could come down. Yes. Are we comfortable with both of those at the same? What's that?
No. I was just gonna say any square root.
Oh, and the square root. Thank you. So we have 3 log of x plus 1/2 log of x plus 1 minus 2 log of x minus 2. Can I split up that x minus 2? No, there's no property that will split up subtraction or addition for logs. Not that we're doing in this class anyway. Amir, did that help? Amir, was that good? For A and B, what I'm going to recommend is, was a fraction difficult to make? My recommendation is to factor out the minus sign when you're doing this problem. So write this over. I'm just being lazy here, doing quote marks to copy what's above. Minus, and then we have 5 log base 3 of x plus log base 3 of x plus 2. If you do this first, if you do it this way first, so you see this one would become a product. This also becomes a product. Then you just add a product over the product ultimately, instead of having like mini quotients. So when you have multiple differences like here, just factor out that minus sign. Hey, Kimmy?
Minus 5 log b to the x, like plus log b to the x to the minus 1. And then go
Can you say that one more time?
to the minus 5, and then you put it to the x to the 5, and then you just add.
Oh, so make this a -5, and then this is a plus. What do you think? Would that be okay? Yeah, that doesn't violate any of the laws of logarithms. That's great. And then you get that it's all a product on top with a negative exponent, and then you move it down. Oh, interesting. I like it. Did you do that with the other one too? With this one? Did you put a -1 up here? It's really interesting. Just make it all a product with negative exponents, then bring them down. Fits together like hand in glove. That's a really nice way of looking at it. I hope that these went well. Was there a question on example 6 I could help with? Was that one okay? Okay. 121. How is this? Should we talk about this one? Well, one way to do this, honestly, is just put it in exponential form. Right now, you could think about it as log of something equals that whole mess. So you could say just e to the mess equals y. But this would, although this is a correct answer, it wouldn't be simplified. I wouldn't give you full credit for it. And you probably could feel that it was an easy way out. So I'm going to do this the way that I'm looking for, which means I'm going to take the right side and compress it into a single expression. So left side stays the same. ln of y equals at -1/2. It's going to become ln of x to the -1/2 plus ln of, shall I just make it the cube root already? X squared plus 1 plus ln of c, nothing much to do there. Can I just divide by ln? No, ln is not a product. I know it's tempting to divide by ln, but that will definitely give you no points on a problem like this. But we can take the right side now, and as we're trying to do, combine them now that there's just logarithms. So ln of y is equal to ln of, shall I make it a fraction? I think I will. And what's on the bottom of this fraction? X to the 1/2. Does that make sense now? X to the positive 1/2? It would have been this times this times this. So I'm just kind of working a step ahead. So now that what's left on the top is, I'm going to put the c in front and then times the cube root of x squared plus 1. I just want to make sure I don't accidentally put the c inside this radical. Am I done? I could turn the 1/2 into square root as well. Actually, let's do that. It's just to be consistent at least. And I don't care which way it is. Either one is fine. And now am I done? Exactly. There are two things you could do right now. You can look at this and say, since ln of y equals ln of this, that y equals this by observation, you can just set the, what's that part of the logarithm called? Do you remember the vocabulary? What's that? It's not a base, that's a good guess. The argument. You can set the arguments equal to one another. And this is done by observation, but you said to, what was the process?
Yeah, I was thinking just put everything, like make even base stuff.
Exactly. So I think you're saying maybe to do this. Yeah, this is called exponentiating, and this is a mathematical way to do it. And e to the ln of y, it's just y, right? It's just the base of matches like we were talking about. You don't have to show me this. You can just do by observation, by matching, set the arguments equal to one another. But that is a Mathematese way to get to the end. Should we rationalize the denominator? In this class, you never have to rationalize the denominator. Please don't get that confused with simplifying radicals. If this said the square root of x cubed, I don't want you to fill out x squared. But rationalizing denominators, it's fun. Everyone loves it, but you don't have to do it. It's not more simple. Yeah? This one, dun dun dun. Step 1. Put the ln's on one side. Yeah. Should I go over that? I'll go over it quickly. Ln of y minus ln of c equals negative 2x. This is now ln of y over c equals negative 2x. How am I going to solve for y though? Yeah, now some people look at the last one and just say that y over c equals negative 2x. You can't just erase a single ln. If you have two logarithmic functions with the same base on either side, then yes, you can set the arguments equal to each other. But here, we rewrite this as exponential. So we're thinking about this as log base e. So this is logarithmic. We're going to write e to the negative 2x equals, should I say y over c? Or say just y and then multiply both sides by c? It's up to you. You can skip little steps like that. Just be careful. Yeah. If you wanted to introduce an ln, if you want to do this the hard way, you could rewrite this as ln of e to the negative 2x plus ln of c. If you wanted to. I don't think that's intuitive though. It's just fun. I'll put an or right there for those of you who want to pursue that way. Let's talk about page 22, because that really was we're doing today. When it says fun one, you know what that means, right? It means extra, right? It's really just for fun. It's not, yeah. You're not going to see it on the test, exactly. The skills, you need the skills for the test, but you won't see anything that complicated. So please don't stress over these extensions or the fun ones. Don't think you need to get a tutor for those. Although I will say understanding it just helps your overall understanding. So it is nice if you could jump that hurdle. And once you can, you should have a sense of satisfaction for getting there. Would it be okay to move things around left and right here? Would it be okay to add and subtract? If we're showing that something's equal, I don't know. It seems like what we did with trig. I would not want to add or subtract anything unless it's on the same side. Maybe I try to add these together somehow. Because we're showing. Yeah, we're just showing them.
That
But since it's not an actual proof, I'd be happy if you happy with it. So. James, do you have a suggestion or comment? Just right now, I feel like what's your suggestion?
Like we should make the right side, you should move it to 1/e to the 2x.
Yeah.
Oh, this right, that part, yeah.
Oh,
Just
interesting.
maybe write that 2x in form. Like,
Yeah.
ln.
Yeah, absolutely. So that gives us a course of action, doesn't it? Does that make sense to rewrite this? Then I guess you got a common denominator.
And then, yeah, and then I put everything in the numerator.
No, it's not.
That's nice.
Yeah. No, never mind.
I don't want to spend more time on this problem, but I'm happy to talk to you about it if you like later on. But yeah, I do want to talk about this page. I think you already started working on this one, didn't you? Some of you did, some of you didn't. This is today's material. So the first part of the homework is to finish this set of problems. Oh no. Oh no. Okay. First part of the homework is to finish the set of problems. And there's finally a Pearson assignment for you guys. And it has all the previous sections, so it doesn't have these kind of equations. I'm going to start with B. Could I just write this as like 1/2 ln of x? That middle term. Be careful. This does not equal ln of square root of x. And they say do two different things. If it's ln of square root of x, then we could move that 1/2 down, but we can't do anything with that 1/2. So the strategy for this is a little different. What's the strategy for this problem? What's that? Yeah, maybe do a substitution because this is a hidden quadratic. How do we know it's quadratic? Yeah, this compared to this is squared of that middle portion. Right? Normally it's very clear. X squared plus 3x plus 2 is equal to 1. That is 0. That's very, very easy to see. But this is a hidden quadratic. It's called quadratic form. If you want, you could do a u substitution or an a substitution. Say that u is equal to this middle one, so square root of ln of x. And then from there, that first term would become u squared minus 3u plus 2 equals 0. And do you agree that that's a little bit simpler to solve in that form? You can continue from there, but I'm going to do it without the substitution. I'm just going to put my square root of ln of x here, square root of ln of x here. Now the question I ask myself is, what are two numbers that multiply to 2, add to -3? Very difficult. -2 and -1. So we have square root of ln of x equals 2, and square root of ln of x equals 1. Are these difficult to solve? Square both sides, ln of x equals 4. ln of x is equal to 1. Let's solve this one first. How do you solve ln of x equals 1? We check to see what your neighbor thinks about this. Ln of x equals 1. What is x? We're doing this one.
Yeah, yeah.
On the count of 3, I want to hear the answer. 1, 2, 3. Wasn't that easy? Sorry. How did you get E? Yeah, so going from logarithmic form to exponential form, e to the 1 equals x. Or perhaps did any of you use just we know that log base A of A, the property of log base A of A is equal to 1. And you could do it kind of by knowing also. So ln of what equals 1, ln of E equals 1. So this one, I don't expect you to know it, but I do expect you to think, oh, there's a little E right there. That's why E to the 4th power is equal to X. So X is equal to E, and E to the 4th. Can I just write that as 4E? Just bring that 4 down. Please, please don't just use logarithmic properties on all other things. It doesn't work that way. So please keep it where it belongs. I'll let you do that one. I feel like you excel at that. Not right now. Let's do this one. What do you think we should do with the 1/2? Yeah, kick it up. Log base 7 square root of X is equal to log base 7 of 2 negative third. Did I do that too fast? From here, we either exponentiate or solve by observation. Does that make sense by observation? Square root of X equals negative 1/8. Is this even possible to solve? I don't know. Let me sprinkle a little algebra. Oh, interesting.
Yeah, why is it negative? Because it's a negative.
Oh, it's not negative, is it? That's definitely an error. That's an error. Excuse me. That's a total error. It was 2 to the negative third, and that is 1/8. I missed that. Don't forget to correct me if you find a careless error like that. Because I'll correct you. Okay, so now X equals 1/64. Should we check it? It does help that 64 is 2 to the 6th power. Does that help at all? No, that's not helpful. All right, never mind. Okay. I was thinking maybe it's to the 7th. Okay. Okay. Is A pretty complicated? Let's do A though. I'm gonna do 2 different ways. Let's do it an easy way and then another easy way. I say the most direct way is just rewrite it as log 3 of 14. Wait, 3, is this pi? 3/14? No, don't just use random stuff and put it in other places. Okay. But yeah, so that's one easy way. Log basically at 14. Instead of doing it this way, I'm going to use a different method. And since we have a variable as an exponent, I'm going to take the log of both sides. Now I get to choose which base I'm going to choose. So in this case, I'm going to choose, what do you think, Christine? Would a common log be okay? Okay, yeah. I'll take the log of both sides. Log of 3 to the x equals log of 14. And how is this helpful? Now the x can come down.
Oh.
And now log of 14 over log of 3. I want you to take a look at the 2 different answers. Change the base. So they're perfectly equivalent. Either one of these is a perfect answer, unless it says write as a single logarithm or something like that. Henry?
I used to not cross, that's okay.
That's so you got ln of 14 over ln of 3? That's fantastic. Anyone want to use log base pi? You could, although that'd be crazy. But acceptable. As long as the base isn't. Would you just check in with your neighbor to make sure they remember the exclusions for the base? What can't the bases be?
Yeah. Basically. Wait.
I want to hear your thoughts. I want to hear your thoughts.
Said go exponential. Because it goes.
Holden, what can't the base be? Can't be 0, do we agree? Okay. Anything else? Is that true? Okay, so just two exclusions. It can't be a negative.
Let's see, like, parentheses one.
Okay. So nice. Yeah, perfect. So in summary, it can't be, or it must be positive except for 1. Okay. So pi is okay? Yeah, it's delicious. For B, the first step would be, and Holden, thank you, by the way. For B, the first step would be to divide by 5, put in exponential form first. And I'll give you a chance to do that later because we're moving on. We're moving on. C, do you see it? Now that first method we used for A is not going to be quite as effective here because you have exponential and exponential. So instead, let's go right to the second method, which means we're going to do what to both sides? Take the log. Which log shall we take? Let's say common log, although log base 2, log base 5, those would be good alternatives, but let's just be a robot and just say, I'm going to take a log, both sides, common, done. Don't analyze too much. And solve for X. It's a challenge. This challenge is an appropriate level for a test / quiz. Speaking of quizzes, I don't have your quizzes yet, I promise. And I have them, but they're just in tray. And didn't look at them. What is the one they call Noah?
Oh, problem track. No one knows. They're just making their own track.
We'll be calling on one person to help us out with this.
Yeah. Getting X minus 1 with 1 minus 2. So no one puts me.
This calculator. No idea. The answer is not an integer.
I think people might use.
Yeah, that was thinking. No, you have to get rid of the 1 line.
Change your base what?
Isn't exactly my strong.
Yeah.
Yeah.
It will be. Yeah. This.
It's my crazy.
Did you get it? I'm gonna call on someone in about 10 seconds. Do you need some more time? Okay. So Hannah, how far were we able to get here? Okay. Cool.
So first, well, yeah, we took the log of both sides, so then we took the exponent out in the front, so it would be like x plus one times log two, like all of it times log two,
Oh, so I had to put in parentheses like that. Okay.
then equals like one minus two x times the log of five.
Are we good? Perfect next step. Okay. And from here, we're able to figure it out.
And you could like put all the x's on one side, but like I don't know what to do after that.
Okay. Yeah, we definitely want to put all the x's on one side. And some people use division to do that. But I recommend not using any sort of division. Okay, so thank you for giving us a direction. Just one direction, right? Okay. Eileen, we haven't heard much from you today. So log two is just a number, so multiply that. So like use distributive property or something like that. I'll give you guys a minute to finish. I like this. I feel like the door has been opened.
Avenues have been created.
Avenues have been.
Lay down.
Oh my gosh.
Thank you, Eileen.
They put X on each side, then you back X down.
Yeah.
Yeah.
Okay.
Make sure your neighbor got to the end. Hold on, was that going to be your recommendation, by the way? Hmm. Did you get it? Okay, so Hannah, do you wanna talk us through what you did from here? We have a
Yeah, I was almost in it. So basically, I think you just do, then you can put it as a fraction on the, or you set as a fraction. So you
well,
can-
I need a next step. Am I gonna make a fraction from here? Oh,
whatever's in the fraction will be equal to each other.
interesting.
I don't know if that's
So you're gonna make a log on one side, log on the other side, like we did before.
like, yeah, like what we did before. So you could put.
Okay, so you got log this is not what I was thinking, but so log 2 to the x times 2, maybe something like that, equals
Equals log five to the two x.
maybe 5
No. wait,
over
five to the two.
5 to the 2x. That's interesting.
So then you could put like two x times two equal to five over two x.
Okay. It's solving for x now. I think it might be a little, and I think we might almost be back at the beginning. Does it make sense that these are equivalent? I really like that idea. So sometimes what the methods we use will work for one thing and it just doesn't work. To switch it up a little bit. Yeah. Oh, Holden, can you finish this off?
Add two X log five to the other side.
This term right here?
Yeah. So
Okay.
add it to the other side.
Why?
So that you can isolate, get X's on one side and factor in.
Okay. So plus 2x log of 5. Okay.
Factor X, so it's X times log two plus two log five.
Plus 2 log 5. Okay.
Now X is you divide what's in the parentheses.
Mm, okay. Are we good? So x equals log of 5 minus log of 2 over log of 2 plus 2 log. Should I try to cancel maybe the log 2's? Why can't I do that?
It's not.
It's not multiplication. It has to be factors to cancel. Crazy kids. Crazy kids. Okay, we're gonna start E. Yeah, that's 233. So take a moment to stretch, zone out, discuss.
Like, this is stressing out. It's like, just 60.
Is this
Yeah.
Wait, that's kind of cool. I like it.
Yeah. I'm taking it tomorrow. Someone got big guy.
Who did?
She told me.
Yes.
Did you get more? Yeah. She said it's easy.
No, honestly, that would probably show it.
Yeah,
Yeah.
Apparently, she said that it's easier than the Scarlet Letter ones. I mean, for books.
Yeah.
It's like less numbers, you know?
I'm just curious, I like my teachers gonna give me like, from like really out of context. Well, no, I know.
Yeah.
Like for the half.
Yeah, the passages are, I think Dr. Long was like saying, no, most of the ones that we went on class.
Okay, I know, but my teacher said it's not gonna be like dialogue going too fast.
Yeah. And that's like the hardest thing, but I'm sure there'll be like quotes though, like just order people.
Yeah. Yeah.
So they were like, yeah.
Oh.
Yeah, I know. Like,
Are you serious? Like,
that like pages about.
yeah, it was like, we talked about her class, we talked about Dr. Long on it, like, that's insane. Oh, but, her, like, my teacher said something which for that is to like,
Wait, like the short answer?
yeah, it's to like find like patterns in like the different, like people's like quotes and stuff. And like,
Like,
so like Tom, so like Tom, like he's just kind of like, he's always like rude, like passive.
And he's racist.
Yeah, racist, exactly.
We just like, don't.
Yeah, it's like always like, find like little patterns that are all
Yeah.
like, memorize like their like, don't know.
Go ahead and finish up your conversation.
Yeah.
That's all you got.
Everybody got scared. Unfortunately, but
And the time is 2:33. Let's finish this up. I give you some time to work on your problem sets in class. Okay, so your attention, please. Everyone's attention, please. Thank you very much. Okay, so E, what do you see? Possible quadratic, right? That's 2 right there. But remember, I said in the beginning that it's quadratic form if this is the square of this. Is it the square of that? It's not. There's a little bit of a problem. But can we get out of this problem? Rhea, do you have an idea?
I did it, but I don't. It doesn't like work for me yet.
It doesn't what?
It's good.
Okay. What's your idea?
On page 3.
Ah. Well, let's see. We could do this. 3 to the 2x. Don't write this down, folks. No, my question is, could you do anything with that? Can we distribute that log through?
No, wait.
Oh, equals, I should say, and there's another problem here, isn't there? And maybe if we move that 4 over, maybe we could get out of this by doing this. Would that make sense? We got out, there's no, yeah. Yeah, be careful. There is no log of m plus n in the scope of this class. Well, what property would allow you to? That's a property of multiplication. So it's appealing to do that, but we just can't. And I guarantee that someone's going to do that on the test. And I'm pretty sure it's not going to be you, Reed. Right now that you've tried it and we've agreed it doesn't work, I'm pretty sure it's not going to be you. But I'm sure that someone else in this class who's not paying as close attention as you will be doing that. So what do we do? Yeah, Holden?
It's not actually that much different from the previous question. I would add 4 to the other side.
Okay.
And then choose either 3 to the 2x or 3 to the x plus 1 to move to the other side as well.
Oh, okay. And then with the goal of doing what?
The log of everything. And then do the x range.
But we still have the log of a difference there, which is same problem. Are we allowed to? Well, let's see if we have something like x to the, I don't know, 4, how could I do this? 5 to the 2x plus 5 to the 3x. Can we do something with that? I'm not sure we could. Shane, you have an idea?
3 to the 2x, also 3 to the x squared. So you can go like 3 and x and 2.
True. I think we need to do something with this. The 3 to the x plus 1. This, I think, is a problem. So let's examine this. You got some good ideas here. I'm going to hold on to this square because I'm hoping this is going to be in quadratic form. Does it make sense that I could rewrite this as a product? Well, I'm going to start with 3 to the x times 3 to the first power. Does that make sense? So it's just equal to 3 times 3 to the x. And remember, quadratic form, to qualify for it, this 3 to the 2x has to be this thing squared, which I think is just what happened. Good catch. Minus 4 equals 0. So if you want, you could say that u is equal to 3 to the x, but I'm not going to do that. I'm just going to say 3 to the x times 3 to the x, and then I'm looking for 2 numbers that multiply to -4 and add to +3. Do those numbers exist? Yes, thank you for not forgetting your 7th grade math. Actually, I guess that's it's like 2nd grade math, adding and multiplying.
My biggest enemy.
So we have 3 to the x equals 1 and 3 to the x equals -4. It doesn't? I see it right there.
But it does.
The solution doesn't exist. So here we have x is equal to 0. How did you get 0? Anything that's 0 is 1. You can put in log form if you want, but just use your general knowledge. And yeah, here, and I hope you know the 3 to the x looks like that. The range is positive numbers, all positive numbers. So yeah, no solution there. X equals 0. Does that even work? Want to check to see if that works? See, 3 to the 0 is 1 plus 1 plus 3 minus 4 equals 0. Okay, got it. It worked. One more problem, folks. Would you please discuss with your neighbor how to use a graphing calculator to solve a problem like this? What's the strategy to solve this on your calculator?
Wait, I'm gonna try something out. Okay, wait. Oh, great, wait. I don't get more.
Can I get a strategy? How are you supposed to do this on a graphing calculator? Yeah, Shane.
So the graph E of the X, negative X and negative.
So you made this like y1 and this one y2. So we have y equals e to the x and y equals negative x. Do you know what these graphs look like in your head? You better, e to the x, better know that. You better know y equals negative x. I'm worried if you don't. Yeah, graph them. And then Shane just said we have to figure out where they intersect. We find the x value where the y's are equal to one another. And I'm going to talk you through how to do that. If you don't know. Y equals, you have them both in. Is the glare too much? This glare is too much. Okay. And I'm going to go over how to do it, but just check it with your neighbor. Maybe they already know how to figure out that x value. This is a key skill for these calculators. Yeah.
If you go like that, then we'll give it to you. Then that's where it goes. Yeah.
Okay, where do I go? Trace? Second trace. Please stay away from the trace button. Don't trace stuff unless you're doing that on purpose for a specific reason, which will never exist in this class. We need to second trace and then go to intersect. So I'm just going to hit that 5. At this point, it gives you a list. Since they can have up to 9 different equations, it needs to know which ones you're choosing. So that's why it's asking first curve and second curve. You can see the cursor right now. If I move it left to right, you'll see it's on that blue one, which matches y1. I'll hit enter. And it switches automatically to y2, which is my only other one. So I hit enter. Now, there's only one place, so I don't think I really need to guess. If you do need to guess if you have multiple. I'm just going to go hit enter because I'm going to be lazy. And there we go. Did you get that same number? Well, negative 0.567143. If you got something close to it, you've done it wrong. And we are, we're looking for that accuracy. So please make sure you can do this accurately. 3 decimal places unless otherwise stated. If you do less, it better be exact, like 0.25. You don't need to do 0.250. Yeah, for approximations, 3 degrees of accuracy. That's all I got for you. So you have time to finish the problem set in the book, in the packet. And if you want to start on the online portion, you can do that too. Completely up to you. Yeah. Let me stop this.